talk about evaluating some trig functions now. Okay, here's a couple of hints that some students find interesting. I know that from Algebra 1, it goes positive, positive. Quadrant 2 is negative, positive. Quadrant 3 is negative, negative. And quadrant 4 is positive, negative. But sometimes seeing the tangent also helps. So if we talk tangent, which is sine over cosine, tangent is positive. Tangent is negative. Since it's negative, negative, quadrant 3 has tangent. It's also positive. And if one of them is negative, then the tangent is negative. But here is a helpful little hint for some people. All students take calculus. Oh, I wish that were so true. All students take calculus. So who's positive in quadrant 1? Well, all of them. Who's positive in quadrant 2? Well, just the sine. Oh, who's positive in quadrant 3? Just the tangent. Who's positive in quadrant 4? Just the cosine. Some students like to write that at the top of their test paper just to see or to help them with some of the problems. Okay, remember, coterminal. Coterminal. Coterminal are two angles whose terminal rays and the terminal rays, of course, are the ending ones. Two angles whose terminal rays end in the exact same place. And so what you have is a unit circle, and angles are going round and round. They stop in the same place. Sine cosine is going to be the same. So you essentially know infinite number of trig values. For example, 17 pi over 4. I have to figure out where that is, and so let's talk 4s. 4 out of 4. Every time you go 180, that's 4 out of 4, 8 out of 4, 12 out of 4, 16 out of 4. 17 needs one more pi out of 4, so you're right there in the middle. You're right there in the middle, the same place as pi over 4. The values here are radical 2 over 2, comma radical 2 over 2, since you're pi over 4. So what is the sign for 17 pi over 4? Well, it's just simply radical 2 over 2, the same sign for regular pi over 4. So that's what that means. If you can get to the place, you can answer the question. All right, cosine for 5 pi. 1 pi, 2 pi, 3 pi, 4 pi, 5 pi is right here. Same place as regular pi, but you have to swing around that many times. Make sure you show me the curly cues. The point here is negative 1 comma 0. I say cosine, you say negative 1. And 5 pi over 4, he's related to the pi over 4s, of course. 4 over 4, 5 out of 4 is in quadrant 3. Since it's over 4, the values are all radical 2 over 2, except in quadrant 3, they're both going to be negative. When I say tangent, you say sine over cosine. Same over same. Tangent is 1. Okay, so it's kind of like a little recap today. They're going to give you little clues like this, and it's going to help you narrow it down. Okay, so if the sign is less than 0, that means that the sign is negative. Well, that's going to narrow it down for us. Where is sign negative? In quadrant 3 and 4. Okay, definitely going down. But the other clue says cosine is negative. If the cosine needs to be negative, you're thinking of a point that's negative comma negative. Name the quadrant. The answer is quadrant 3. What an easy question if you know all students take calculus. Okay, here's another example. I've got a sine and I've got a cosine. Okay, let's draw a nice picture. I'm going to put the angle and the triangle in quadrant 1, since it's positive, positive. So make sure you go from origin into the quadrant, use the x-axis, there's theta. Sine, let's go ahead and write some things here, is opposite over hypotenuse. And cosine is adjacent over hypotenuse. So let's put these numbers in the right place. Okay, sine. Opposite leg needs to get radical 5. Hypotenuse needs to get 5. The hypotenuse is always positive. Cosine of theta, the adjacent leg needs to get 2 radical 5, and the hypotenuse is 5. Perfect. Find the exact values of the other 4. All right, I'm going to go ahead and write down the 2 that they told us. So they told us sine, and they told us cosine. So the other ones they want us to find are tangent, and then the 3 reciprocals, cosecant, secant, and cotangent. Okay, so they told us sine is radical 5 over 5, and they told us cosine is 2 radical 5 over 5. So let's go ahead and find the other ones. There's a couple ways you can do this. You could take sine, divide by cosine to get tangent. Some people like to just look at the picture and do opposite over hypotenuse or adjacent. Either way, it's going to be the same. I think opposite over adjacent is just a little smaller than this. So radical 5 over 2 radical 5. The radical 5's cancel, and we get 1 over 2. Make sure the 2 stays in the bottom. Okay, let's go ahead and reciprocate some of these. Cotangent's easy. Reciprocal is going to be a 2. These are going to need a little bit of work here. So I reciprocate and get 5 over radical 5. And this is going to be 5 over 2 radical 5. So let's go ahead and rationalize, multiplying top and bottom by radical 5. Radical 5 over radical 5. Okay, so what do we have here? We have 5 radical 5 over a plane 5, which we're going to have to simplify. Cancel, cancel, and the answer is radical 5. Let's do that again. We're going to get 5 radical 5. The denominator is going to have a 2. And then this makes a plane 5, but those plane 5s are going to cancel. And so the final answer is radical 5 over 2. There we go. Okay. Find the exact value without a calculator. Without a calculator, I don't know 20 degrees. It's not on the unit circle. How am I going to do this? You can't cancel 20s. That doesn't work. It's sine of 20. He goes together. But I know that I can maybe use some of my trigonometry knowledge for this. If you see sine over cosine, how can you write that? Sine over cosine is tangent. But of what angle? Since it's sine of 20, cosine 20, it's tangent of 20. Now this trick only works if the angle is the same. Let's say that angle must be the same. Okay. And so the answer is simply 0. Nice. So this is a question of, do you know your identities? Okay, next one. I've got sine being positive, cosine being negative. The cosine's negative, the sine's positive. Let's draw this picture in quadrant 2. Quadrant 2. Put your pencil on the origin, go into quadrant 2, and there's theta. Okay, let's put some information now. Sine is opposite over hypotenuse. Opposite's 1, hypotenuse is 3. Now we got to get that other leg. I think we're going to have to use some Pythagorean theorem here. So a squared plus 1 squared equals 3 squared. A squared is equal to 8, and the square root of 8 is 2 radical 2. Okay, except that's not right. What do you mean it's not right? I forgot something. I forgot something. Do you see how it's going left? Going left, you need to put the negative sign by yourself. Let's put a little star here. Left and down need negatives. Okay, and it might not be clear and it might not be expressly stated in the problem, but you have to make sure you add those negatives on yourself. Okay, it says find each of the 5. I'm going to also write down sine just so I can do my reciprocals a lot easier. So sine, cosine, and tangent. And then the reciprocals are, go ahead, tell me, cosecant and secant and cotangent. Okay, sine is 1/3. So cosecant is 3. Perfect. Okay, cosine, let's look at our picture here. Cosine is adjacent over hypotenuse. -2 radical 2 over a 3. Tangent is opposite over adjacent. 1 over -2 radical 2. All right, let's go ahead and clean these guys up a little bit. That one's okay, that one's okay. This one needs some work. So let's multiply top and bottom by radical 2. And that's going to make negative radical 2 over a 4. And now it's flipping time. Flipping time. Let's go ahead and reciprocate this one and get -3 over 2 radical 2. And, I don't want to put that radical in the bottom, so I'm going to go ahead to the original one here and reciprocate that one. Flipping that one is -2 radical 2. That was a lot easier. Secant needs to get rationalized, so let's go ahead and multiply him by a radical 2, giving us -3 radical 2 over 4. Well done. It practices SOHCAHTOA a little bit, our reciprocals, pictures, all the stuff. Okay, we got one more here. We have to practice these so we get good at noticing when we have to put the negative signs in. Okay, tangent is positive. Sine is negative. So if sine is negative, that means we're in either quadrants 3 or 4. We have to go down. Okay, which quadrant has tangent positive? It's got to be quadrant 3. It's got to be a negative to make a positive. Okay, so here's our picture. Here's our theta. And it says tangent, which is opposite over adjacent. Opposite over adjacent. Wait a minute, that's not right. What's wrong about that one? Ooh, they're going to have to get some negatives. Negative and negative. Now, it doesn't say it there because the negatives canceled and made a positive, but you must remember to put them on your picture correctly. Now we'll have to do some Pythagorean theorem. -1 squared plus -2 squared equals c squared. And c is, well, c squared is going to be a 5, so c is going to be radical 5. Does the hypotenuse become positive or negative? Well, it's always going to be positive. I think we said that a couple times. Okay, sine of theta, cosine of theta, tangent of theta. Sine is opposite over hypotenuse. -1 over radical 5. Oh, we don't want to say that, do we? We'll say negative radical 5 over 5. Cosine is adjacent over hypotenuse. Oh, let's not leave it like that. Let's go ahead and rationalize. -2 radical 5 over 5. I definitely like writing down the original one and then rationalizing in my mind if I need to. But it's helpful to have that one written down. Tangent, they told us, is 1/2. And the 3 reciprocals. Cosecant of theta is, oh, don't reciprocate that one. Reciprocate this one. Negative radical 5. Do you see why I like having the original one written down? It makes me not make a mistake, and it also makes this easier. Secant of theta is, oh, let's flip that one. Negative radical 5 over 2. And cotangent of theta is 2. There you go. Okay, I hope this makes sense. Here's one for you to try. I really want to see a nice, accurate graph with all those negatives, and good luck.